start recording. So you're going to see very little of me today. This is going to be it. I get to be a spectator because I'm going to be turning things over to your trusty TAs for helping you through your formative assessment review as well as a couple of demonstrations. So just to make sure we are all literally on the same page, I have formative assessment 3 that we're going to talk about. That closed last night. I updated grades this morning for that. And Bladimir had updated his example because, like me, he can't leave well enough alone. And I just heard from Nikki that she might want to change hers later too. Yeah. Because you don't see typos until you're actually presenting. That's how it works. So he decided to add some things, and so we have that version, and then Nikki sent hers. So I announced this via email yesterday, but in case you didn't see that yet, here's some places to download. And also Bladimir's office hours start a little bit later on Thursday, and we will be starting count outcomes depending on how long this stuff takes. So if it takes more than today, then that's fine. In terms of things you can be working on, I also put up formative assessment number 4, which will be due after spring break. So you should be able to answer all of those questions by the end of this week. So you can get it done ahead of time, you can get it done over break, or you can ignore it until the Monday we come back. Your choice. I also opened homework 3, which is based on example 2B, Ordinal, so you can be working on that as well. And I had already posted the plan for what you want to do for homework 5, which would be the next thing. So plenty of stuff to keep you busy, just in case you didn't have anything else to do. I try to help. All right, then make sure I'm recording. Yes, I am. Excellent. I'm going to turn things over to the TAs then. So Bladimir and Nikki, if you want to come on up, or both of you or one of you, I don't care how you want to do it. And I have the Word document here, Bladimir, that I sent you that I made to talk about intercepts and thresholds.
Yes, and you want the
So,
other thing to show.
Do I also have the PowerPoint? I can have the PowerPoint. Which PowerPoint?
Lecture
2?
2?
2. Yeah, this class starts at 0. So it's probably 2.
Yes, lecture 2.
Yeah, I used to try to make the homeworks and the numbers align, and then eventually I just gave that up. That's why some classes start at 0.
That's fine.
Yeah, it just...
I like the ABC kind of distinction.
Mm-hmm. Yeah, that's like part 1, part 2, part A, part B. Okay, here you go.
Awesome.
Be sure this is the one that didn't eat the equations. Okay, they're in here. Good.
Yes,
All right.
I will be using that.
Okay, then I'll turn it over.
Okay, hi everyone. I hope you're having a good Tuesday. And today, yes, it is Tuesday.
Yeah, happy garbage day.
Happy Garbage Day, yes. So today we will be discussing the questions from our formative assessment 3. I will be talking specifically about question 1 and 2. I read your answers, so I would like to share some things, to check other things, and at the end, if you have more questions, we can talk about like the overall picture of the topic we are covering in class. So first of all, regarding question...
Can you please share the screen? We cannot see the screen.
Oh, sorry for that.
Thank you.
Thank you. My bad. Don't blame them, blame me.
No, thank you.
Okay.
I haven't even done anything today.
There you go.
Thank you, Lisa. So, how do you know what kind of conditional distribution is most appropriate for each type of categorical outcome? And we have seen binary, ordinal, and nominal. Who can help me with this? How do we know what kind of conditional distribution is most appropriate? And I have a clue. Number of categories. That's one point to consider. In the case of binary, for example, what kind of conditional distribution would be a good choice for that type of response variable? Bernoulli, exactly, which is a special case of the binomial distribution. Now, in the case of categorical, ordinal, or nominal response variables, what kind of conditional distribution we could use? It is the same. The logic link function will change, but the conditional distribution is the same. Starts with M. Multinomial, exactly. So, when I read answers, I think that there is some confusion regarding the outcome that we have, the conditional distribution that we may use, the link function that we will use, and the model name. Sometimes we know that we can use some concepts like we can change or use names and concepts like interchanging those things. But sometimes it is important to use the specific words and concepts to describe what we are modeling or what we are analyzing. So when we have binary outcomes, as you said, we have a Bernoulli conditional distribution for the response variable because we have zeros or ones, for example. And we can use a logit or probit link function. And we can have models, for example, the binary logistic or the binary probit regression. Do you have any question about that order? The elements we are looking for, we have an outcome, we have a conditional distribution, a logit link function, or well, a link function that can be logit or probit, and we have a model name, okay? But now, when we have categorical predictors, it's not the same if we have ordinal or nominal response variables, but we are using the same conditional distribution, which is multinomial. However, the link function will be different. So, if we are using a logit function in the case of categorical ordinal outcomes, what is the specific name for that?
That's question 3.
Oh, sorry.
Are you still
You
my
are right.
question?
I will take all. No, sorry for that. Yeah, you are right.
Great, I'll go eat my sandwich.
But that's because it's related to the first question anyway. But yeah, you are right. Sorry, Nikki.
No worries.
So regarding question 2, but that was like the forecasting? Yes.
Foreshadowing.
Foreshadowing. Thank you, yes. So you will cover that in question 3. Now, regarding question 2, what are intercepts and what are thresholds? And how do they relate to each other? Can someone help me with this? What an intercept is? And we have seen this in class. People on Zoom can also participate, okay? What is an intercept?
Intercept is the predicted outcome when the predictor is 0.
Yes, that's the standard definition. Yes. Now, in our context, what we are predicting, for example, in a binary logistic regression, that's the proportion of ones. So in that case, we will be predicting the proportion of ones instead of the proportion of zeros. There you have a clue about what a threshold is in this context. What is a threshold?
The log data probability of the higher, the lower count.
Yes, exactly. In this context, we could interpret the threshold as the probability of being classified in the lower category instead of the upper category. And this makes sense especially when we have categorical variables, like in this example here. So,
You can do the picture if you want. I made it for them this morning. I made you guys a picture.
yes, but I would like to show this slide too. For the case of, yes, that's for logic. I'm looking this one. I'm looking for this one because in this case, the threshold would be reflecting the probability of being classified as 0 or 1 instead of 2 and 3. But the intercept would be reflecting the probability of being classified in groups 2 and 3 instead of 0 or 1. Right?
Yep.
Is that clear?
Yeah.
Awesome. Now, as Lisa mentioned, many of you mentioned something about points with respect to thresholds, and that's good, but not clear or not clear enough, because you can see that when we assume that we have something continuous, we can have thresholds which are these points. So we can assume here that this is the flip over point. In this case, this is at -1 on the x distribution of our, let's say, latent continuous variable. In Probits, yes. So here you can see that in our context, this means that we are predicting the probability of being classified as 0 instead of 1. So, and what's the relationship between thresholds and intercepts? Now that you are looking at this picture, what do you think that's the relationship between thresholds and intercepts in this context? Gestures? Like what? The opposite?
Yeah.
Yes.
Multiplied by 51.
Yes, exactly. And there is a concept for that.
Additive inverse.
Yes, exactly. Additive inverse. So if you are predicting thresholds, or if your software is predicting thresholds, you can take that number and multiply by -1 and you will have your intercept. But now that will represent the estimated probability in Probits or Logics, right? To be classified as 1 instead of 0, or being classified in the upper category instead of the lower category. And those are the two things. Do you have to?
Yeah, just to
But
follow
something-
up on that, so like where the threshold is, like this is where zeros turn into ones.
Here.
But if you go with the actual number that corresponds, so I picked this one on purpose, it's -1. That means like cumulatively, we're up to almost 16% of the distribution. That means 84% is out of this way. But if you think about what 16% is, that's the proportion that has a 0, not the proportion that has a 1, because you're coming from the left. Whereas if you came from the right, then this would be like 1 past the mean, and that would be a positive 1 to describe the 84% that's on this side. So it's like the point where it flips is referring to the 0 probability instead of a 1 probability.
Exactly. Thank you, Lisa.
So, and I need to put this in my slide deck next year. That's what I-
Yes. Your turn, Nikki.
Oh, yay. Great. Thank you, Bladimir.
Yeah.
Hi, Roomers. Hi, Zoomers. Okay, so I am looking at,
Let's think back.
well, I think I'm maybe better this time around. I don't know.
Yeah, it's my device, so I don't expect. There we go. There's the questions.
Great. So I am looking at questions 3 and 4, and I similarly looked at your answers, and you all did a great job. So I'm going to ask you all, what's the difference between a cumulative and a baseline category generalized logit link function? And people did great on this one. Who wants to start with a cumulative logit? What does that mean? What does cumulative imply?
Feel free to read from the screen.
Yep, feel free to read from the slide. Yay! Excellent. Yes,
So
lower.
0 versus 1, 2, 3, 0, 1 versus 2, 3, 0, 1, 2 versus 3.
Absolutely. Yeah. So in a cumulative model, what you're predicting is you're splitting up your data. We're dealing with ordinal data, so that means we have multiple categories. It's beyond the binary, right? So we have at least 3 categories. This example has 4 categories. And we are changing our submodels so that we're consistently predicting the lower versus higher categories. And how we do that is we start with a 0 versus the rest, a 0 and a 1 versus the rest, a 0, 1, 2 versus the rest. So that's the idea of cumulative, because we're slowly adding kind of the 0, 1, and 2s to the lower part of the model. And so the key idea here with the cumulative is like whatever model you're in, you're predicting the lower versus the higher. Would you like to add anything?
All the categories get used.
Yes, all the categories get used, as indicated by this lovely slide. Great. Excellent. Okay, what do we think about the baseline category? Where did this one go? This might be a different slide than what I generated. Nope, just kidding. Great. Okay, so what is the baseline category for generalized logit?
So now we have a reference and compare the reference with the other categories.
Yeah, great. So if we notice here, we're selecting what our reference group is going to be, and then we subsequently compare each of the categories to that reference group. And to Lisa's point, a key here is that you're only zeroing in on whatever model, whatever you're including in the model. So in the first submodel, you're looking at the difference between a 0 and a 1. And then when you go to the second one, now we're zeroing in on a 0 and a 2. And we're predicting things. So whereas the last one was lower versus higher, the key one with this one is reference versus each other. Any questions on this one? Y'all did great on it. Okay, so then the next question we have, I'm going to see if I can do it. I did it. Okay, so the next category is for what kind of categorical response types and then research questions would a cumulative logit link function be more appropriate than a baseline logit link function? I'm category generalized and vice versa. So let's start with our cumulative. What is an appropriate variable type that we would analyze using a cumulative link function? You all also did really well on this one too. Yes, absolutely. Ordered data is categorized an option for the cumulative function. Why does the mouse, there we go. It seems to get stuck in the corner. So when you have ordered data, and you're essentially moving kind of your categories cumulatively across the different submodels. I actually really appreciated James's example for a cumulative, for a research question. Do you mind sharing it?
I wrote what factors influence the level of satisfaction in a restaurant.
Yes, so for Zoomers, what factors influence a customer satisfaction like at a restaurant? So our response options in terms of how we're thinking about it would be satisfaction. So we could have low satisfaction, medium satisfaction, and high satisfaction. So this first model would be low versus anything that's higher than low. The second model would be medium, anything that's higher than medium. And because we only have 3 response options, we only wind up with 2 submodels because it's always C-1 categories in terms of the number of submodels that you run. Absolutely. Okay, so then the next question is what types of variables, I'm going to make that other point in a second, I think.
Nikki, I'm sorry, but can I jump in with the ordinal that we just covered? Because if we think about the ordinal outcome, so I mean, does the Likert scale? If the survey has Likert scale, then can we use ordinal model, cumulative model for that?
Yes, absolutely. Lisa's giving you a double thumbs up. Basically, if you are analyzing survey data and you have Likert style options, so like, you know, think agree, disagree, but don't use agree, disagree scales because they're bad cognitive load for people. But anyway, but like agree, disagree type questions, you absolutely should use a cumulative logit. And I'll get to the other point, I promise. It's in my notes. Okay, so what about the example of a baseline model? So remember, the 2 questions are what variable type, so like what outcome could we be predicting, and then what's a research question associated with it. So let's start with the first. What type of outcomes are we looking at with this model? You can read the slide. If the other one's ordinal, we've already talked about binary. In previous lectures, we've talked about ordinal, which one's left for right now.
I think baseline.
Nominal, yes, absolutely. So nominal is a variable where you have different categories, but there's not necessarily an inherent order to those categories. So most of your demographic questions are going to be examples of nominal variables. I actually really appreciated Sora's example for a research question using nominal. Sora, do you mind sharing?
Yeah, sure, why not? So what I wrote the possible research question would be, is there a significant relationship between college GPA and employment? And so there are a lot of job options, so I just think about choosing only 5 jobs for the possible options in this case.
Yeah, so in Sora's model, let's say we're predicting whether or not people become teachers, people become lawyers, people become doctors, and people become quantitative methodologists, right? We really want to know about quantitative methodologists, so we're going to set that as our reference category, and we're going to compare each of those jobs to the quantitative methodologist. So model 1 could be quantitative methodologist versus teacher. The next one would be quantitative methodologist versus lawyer. And then this one would be quantitative methodologist versus, what was the other one I said? Doctor, I think? Doctor. Yep.
The useful kind, you mean.
Yeah, MD doctor. Yes, so again, with this, we're seeing C-1 number of submodels. So if we have 4 categories again, you're going to have 1 fewer submodels to make all of these distinctions. One thing that I did want to clarify for folks is that while cumulative is the preferred, I'm putting that loosely in quotes, method in terms of the cumulative predicting ordered categories, I'm going to hop back to this. You can use a baseline category to analyze ordinal data. So it would essentially be, going back to James' example of restaurant satisfaction, you could compare it low versus medium satisfaction, and another model be low versus high. It's just how you set it up, and that's a property of ordinal data. It's a measurement property of like the types of variables have all of the lower classifications embedded in it, so we could treat it like nominal data even though it's ordered. However, you can't go the other way. So Because nominal does not have an inherent order to it, it would be inappropriate to use a cumulative link function because there is no underlying order to kind of account for it. Cumulative makes sense in terms of the type of data and what you would likely want to predict, but you could use a baseline if you wanted to. Anything to add?
I was going to say an example of when you might do that is if you're interested in why people pick particular categories. So like extreme response styles is an interest in survey research and measurement. Like who is willing to say extremely instead of just a little bit? So if you're really interested in predicting like what is the logit of someone selecting the extreme response versus the middle response versus the extreme the other way, like you really care about the choices, then you might have a nominal type model that zeroes in on those choices.
Cool.
So
That's a cool example.
that's a whole thing. IR trees and whatnot. It's a thing. Yeah.
You say things that sometimes I think you make up,
No,
but
it's a real thing, I promise. Judges, really? IR trees are real? Anyone? They're like, yeah, I know what you're talking about. Look it up. It's a
okay,
thing.
I'll believe you. Are there any questions about these two formative assessments? Okay, great job, everybody.
Great job, folks.
Good.
Yay, now it's Bladimir's turn.
Okay. So yeah, I will stay.
So your thing is in the webpage. You can find your way over to that.
That's here.
Yep, there you go.
Great. So this is the second part of the example. Can I leave this up? Yes. Now I feel better. Great.
Yeah, go ahead and mop the short, people.
Yeah. So this is the second part on the example about how to use the things that we are learning here in real situations, specifically for a research project trying to predict the relationship between academic and socioeconomic factors and the probability of being admitted into selective higher education in Chile. And as I told you the last time, there are many materials in the folder. One of them is the set of slides that I showed you with the summary of what we did and the findings. There is a guide that tried to explain like some of the things that we did and some of the things that we think about when we were working on this. And then you have this material, which is an updated version of the code that we use, how to conduct research using R. And I updated this because I thought that the previous material was not enough. And after some questions, I thought that would be a good choice to update this thing and try to give or state some things like in a clear way. So I hope you can use this as a reference. And now I will give you some description about the content. First thing here, this is an markdown file, and I like this kind of files using markdown in R. So if you are interested in creating your own files like this, to give examples and give talks, you can also create slides, you can create PDF and Word files and HTML files. This is awesome. If you are interested in creating your own files, you can visit this website. So here, first, you have like some characteristics of this file. This is not important now. And here you have the packages and a brief description about the purpose of these packages. Most of the time, I try to load or to include the packages that I'm using and not to load things that I won't be using, because then I don't know why they are there. So here you can see that we have some of these common packages and this one, which is related to the R-square measure that we used. And for technical details, you can visit or read the original paper. There is the introduction. So the first step, of course, the data sets. Here I'm using the read CSV function too. So this will load the data into our R environment, and depending on the folder that you have your data, you will have a different address there. Once that's loaded, you can work with them. So for example, in the admission process, we have 4 data sets because we have like 4 stages. First, we have the registration of students with information, with individual and school information. Then we have socioeconomic information from students. We have information about the applications that they made, and we have the admission results. All of this information is compiled in different data sets, so we must merge this information before doing or conducting any analysis. So here you can see that using this pipe command, here you have like a description, but basically that command is saying do this and then this and then this. Is chaining code, and it's pretty good because you don't need to create objects and then manipulate those objects. No, you can create one object and say or tell to R, please, that this object will have all of these characteristics. Now, the problem is how to fix mistakes, how to fix code. Because if you don't know what you are doing, you won't know where the error or mistake is. So right now, I don't like this type of code, but back in 2021, this was useful, and you can save time if you learn how to use pipe commands. And here we are using some verbs from the deploy R package. You have some description there, and all of those things I learned how to use them thanks to Professor Brandon in this course that will be available for next semester, Computer Packages for Statistical Analysis. I think that's a pretty good course. So we are creating our objects dataset by dataset, and we are merging that information. For example, well, not here, but here I'm showing, or I'm exploring the first dataset, and I realize that we have some weird schools with this code 999, which means nothing. So we remove these schools here. So this kind of tedious job is the thing that you must do after before conducting any analysis, because this kind of errors then can be hard to identify once you are analyzing your model results. So, okay, here we have more data sets, but I'm basically doing the same thing. I have the original data set, I'm selecting some variables of interest, and I'm creating new variables based on that information, and then I'm taking only the variables that I'm interested in. That's what we are doing here. And we must merge that information using, in this example, we are using left join. So with left join, you are telling to R, the thing in the left, that's my main data set. So please R, add the information in the data set to the right using this like ID variable. mrun is the student ID variable. So now, for each student across the 4 datasets, we are adding information. And at the end, we have this dataset which is called, to me, just that analysis. Not very descriptive, but it is what it is. So here we have information for each student, the GPA, the name, ranking, these are the scores, gender, type of school, the school sector, all of the information that we will be using for our analysis. Second step, sample description. And here, when we were doing this, we realized that this sample size, we were working with this sample size at the beginning, because we assumed that after the students receive their scores, they will be applying for selective programs. We assume that because if they had the scores, so they would be able to apply. However, we realized that not all the students with valid scores were applying to selective programs. So we were overestimating the probability of not being admitted because many of the students didn't apply. So, and we realized that because we were looking at the model and the logic of admission was like 4% when we went from logic to props. And we said 4%? No, that's not correct. And looking at the data set, we realized this extra filter that we considered at the end. And here you can see how that's translated into code. So basically we filtered our data based on the application. Now we have more code to analyze our data. And here you have a table with proportions. You can use this code to do this. Now, personally, I would prefer just to have individual tables and then put those data into Word. This is, look at this, a lot of work just to have this table. Even worse, if you are me, you can have like a table in your art document which is not needed because then you will put this information into Word tables. So I don't know why I did this, but I wanted to show you this in case you can use it for HTML files, because you can change the content and you have this organization for your data. Now, third step, bivariate analysis, because these things were univariate. So doing the same thing, computing means, we have here the means for the admission factors, for the language scores, math scores, NEM scores, and ranking scores. The means according to different socioeconomic variables and school variables. And of course, plots are a better representation of that information sometimes. So these are the plots for the information in the table. And that's for family income, and this is for mother education, but I forgot to include the labels there. Sorry for that. Yes, that's the problem. Yes, that's the problem. Okay. Sorry for that. Now,
It's okay.
third step, binary logistic regression, and within the third step, the first step when we are modeling something, it is to see what the model is doing. So what's R doing? Here we have our empty model. ADM stands for admission result, 1 admitted, 0 not admitted. Fitting this model, we have this set of results, and this is our intercept in logits. So that's the probability in logits of being admitted in the 2021 admission process to selective higher education in Chile. What is that? You can see here that using the inverse logit link function, which is taking the exponent of that number over 1 plus the exponent of that number, we have this result. If we see what's the proportion of ones in our data set, it is this. So R is doing what we assume that it's doing, which is estimating the probability of being admitted. Now we feed different models. This is the full model, as you can see here, with all of the predictors of interest. Then we feed this second version without the school type because it wasn't statistically significant, and the likelihood ratio test to see that this newer version was better in terms of relative fit. And we also had a third version without education mother. The likelihood ratio test said the third model is better. And here we have the multivariate wall test just to see what the significance of all the slopes was. And here we had to fit the model again because the surrogate R square works in probits, not logits.
Of course.
Because of this idea of the latent continuous variable. So These are the results that I showed you last time. Here you have the surrogate R square. So after fitting 3 models, we can see that our predictors are able to account for approximately 10% of the variance of the applications or the probability of being admitted, which is good because we assume that academic factors are the only factor involved in the probability of being admitted. However, that seems not true because with the other predictors, we were also able to predict some of the variability in the probability of being admitted. Here you have the exponents to then compute our odds ratios, our effect sizes, and create some plots like this. And of course, why not, the estimated probabilities of being admitted. So we have our results, right? We have the odds ratios, and we wanted to say, okay, but what's the difference in terms of probability between males and females, for example? What's the difference? So after talking with Lisa, we realized that when we are interested in differences, we are holding the rest of the attributes in our model constant. How is that translated into code? Right now, yeah, these are linear combinations. Right now, our intercept is representing the probability of admission in Logistic when all of our predictors are 0, and that's for the reference student. What's the reference student? The student with academic scores equal 550, male, yeah, this should be female, male, from family quantile income 1, who attended a public school, okay? That's our reference student. So if you want to see what the difference in probabilities is, you should change each attribute holding the other things constant. And that's what we did. So computing these probes, at the end, we had this table. So here you can see, for example, comparing males to females, how the probability of being admitted changes when you are male from quantile 1 compared to when you are female from quantile 1. They are similar. However, that's not clear, so we created another plot, which is the last plot that I showed you last time. And here we can see that across different quantile family incomes, when school sector. Sorry, I forgot to put school sector, but these colors are for school sector. Blue is private, green is private subsidized, and red is public. Okay, sorry for that. So when we compare those things holding constant quantile family income and school sector in general, we can see that males had a higher estimated probability of being admitted compared to females. And we can also see within females and males some differences according to the school sector. So that's like the takeaway to me. We cannot consider that all students have the same probability of being admitted just because they take the same test. That's what the admission system assumes, that because they were exposed to the same curriculum, they will have similar performance in the admission tests that are supposed to measure the knowledge related to that curriculum, so they will have similar probabilities of being admitted. That's not true for us. Questions? I hope this can serve as reference for you. If you have more questions or comments, just let me know.
I have a question.
Yes.
So if you wanted to include the people who took the test but then decided not to apply, how could you change this model to accommodate that?
Yes, that's a good question. Well, we will need different outcomes for that, right? Could that maybe with path analysis?
Or shadowing.
Yeah.
That's your next example.
Yes, you are right. Yeah, because then we will have different kind of results. And yeah, that is something that I will be talking about when we will cover path analysis. Yes.
And
Thank you.
Erica, since you're here, wasn't this your project last year? What'd you do?
I did, well, I tried to do an ordinal model, but it didn't meet the proportional odds assumption, so I did a nominal model instead, predicting different, like outcomes of process in admissions.
So you can differentiate people who didn't even try from those who did. And
Yes.
among those who tried, who got in and who didn't.
Exactly. Yes. Can I say something else?
Yeah.
This is for next semester, maybe, or for next year. Here, yes, we were mixing up these school attributes and individual attributes. Chan chan chan. So we also had only main effects, but methodologically this is also weird. Cluster attributes and individual attributes in the same single level model. What do you think about that? You can say that that's weird, and it is. So next year you can learn about how to do this using cluster multi-level models, the thing that I did later. So we also have an example for that. Thank you for your time, and thank you, Lisa.
Yes, you do the best you can until you know better, right?
Yes.
That's the constant theme. All right, Nikki's things are in a different folder. Un momento. Okay, here are your documents, so I'll let you open and
Great.
navigate it through.
This is so high.
It's good class.
You're very tall. I think I'm just going to open all of them. Well,
I think I have Stata on that laptop, but if not, if you right-click, you can open it in TextPad.
okay. License has expired.
Yeah, that's what I. We'll do it.
Sorry.
No, it's okay. Yeah. So if you right-click on it and then that, it'll open as a text editor, and then you can blow it up like that.
Oh, yes. This is reminding me I have a question for you after this.
Yeah, I forgot to send you that stuff, didn't I?
No, that's fine. Okay, I'm going to start with the claim. I'm going to start with the PowerPoint first. Okay, so I have an ordinal example for you all. And this, I guess, story comes from a previous research assistantship that I held, where we were evaluating a campus program that was called First Gen Hawks. And so First Gen Hawks is geared towards first generation college students. And so first generation college students are students whose parents don't have a college degree broadly. I'm also a first generation student.
Represent.
Yeah. Where was I going with this? First generation. Oh, because of how the university classifies first generation students, international students are like automatically excluded by default, which I think is problematic, but that's what the university does. So there are domestic first generation students. They come in their first year and they are invited to apply to this program. The program is designed to provide support to new undergrads as they transition to college, essentially. So they take 2 cohorted courses, both in the fall and the spring. They meet regularly with peer mentors, many of whom are also first-generation students. And then they also receive academic support and coaching from university professionals, staff professionals. Broadly, the questions that we were looking at, I need to stay in front of the thing. Sorry, Zoomers. And now I can see you. Okay. So the guiding evaluation questions for the assistantship, we were broadly interested in does first generation participation, don't like the causal use of effect there, but I didn't update these slides clearly. But do they relate to academic performance, right? We would hope that they're participating in this program that's supposed to support them. Maybe they have better academic outcomes and persistence, so they're like returning to the university year after year. What's working well within the program delivery and what might be improved. Importantly, this was a mixed methods evaluation, and so this second question was really more answered by some of our qualitative projects rather than quantitative ones. And then what aspects of the program are valuable according to students, which we actually used document review from assignments that students turned in because they had reflection questions on their experience within the First Gen Hawks program. So we had a ton of quantitative data, and it comes predominantly from university records. So this includes like enrollment information, GPA and performance type stuff, probation, and the number of grades that folks get from DFW. So I'd be happy to do a count example. Our data also comes from a survey that's called Excelling at Iowa. Excelling at Iowa is basically a survey that's sent within the first few weeks of the semester as like an early kind of alert system. So if students respond a particular way on Excelling at Iowa, they like automatically deploy resources for students. So let's say somebody says, hey, I'm struggling with chemistry. What they would do is they would prompt the student, oh, have you heard about the supplemental instruction? Have you heard about tutoring? Different things like that. So it's really designed as like a check-in for students to kind of catch students who might be struggling. What's nice is this data also is used for secondary purposes like this project evaluation. This data is often used in research projects, at least the ones I'm involved in. And then as I mentioned, we did some qualitative things. So focus group with stakeholders, we did a review of peer mentor note logs. Those were hysterical. And then also the First Gen Hawks student reflections. So generally, students kind of arrive. They take, the first several weeks is when Excelling at Iowa data is collected, so it's a very specific time point. We had focus groups here in the fall, and then at the end, we kind of refreshed our data about academic performance data from the university. So we got like their term GPA, their cumulative GPA, the numbers of attempted credits, earned credits, like anything you could possibly think of that could be considered academic performance, we have it in our data set. So then in the spring, we moved into more focus groups with the students. And so me and Nick Bowman, we actually went to the different classes because they were required. And they were kind enough to dedicate a class session to us to come in and like do these focus groups. So we had really high participation. End of spring semester, we would grab another snapshot, and then summer is usually when we're kind of developing the report and whatnot. This is no longer my assistantship, but I learned a lot the 3 years that I was the research assistant for it. So for the group of students that we're talking about, there are 132 First Gen Hawks students who started this past fall, so fall 20, is that right? No, 2023? I lied. This data is 2022 because I'm not part of the project anymore. The latest data I have is from last year. So these are students who started last fall 2022. There were 132 students who started. Again, by definition, they have to be first generation, first years in First Gen Hawks, and then they come from all different colleges across the university, but a lot of them are from the College of Liberal Arts and Sciences. And then we created a comparison group, and we really wanted to kind of distill it and make it comparable to students. And so we focused on first generation students. That was our main kind of like inclusion criteria for our comparison group. But the key difference here is that they're not in First Gen Hawks, obviously, but they're also not in what was called Gear Up or TRIO programs. Those are also first-year support programs that are pretty helpful. Yes?
Did they choose not to be in your program? But they, even though they were eligible,
They were all eligible, and
they self-selected?
yeah, they self-selected out.
Okay.
Yep. Yeah. Where we're at right now in terms of enrollment, I don't think we've reached the enrollment cap. So basically any first-gen student who's like, I want to be part of the group, we let them in. So, but numbers, we have 132, and then we have 799 students who are in the comparison group. And I think that's the last slide. Yep. So this is background context. Are there any questions about background context of the program? Great. So the analyses that I'm going to show you aren't actually any of the analyses I did for this project, but I realized that I had access to ordinal data within this data set, and I curated this example. So it's not this next part is not quite as polished in terms of what Bladimir was showing in terms of like an R markdown, but these are real data still. So before I get into the actual analysis file, I wanted to go through my cleaning file to just highlight the fact that just because somebody has data and it reasonably should be clean does not mean it's actually clean. And you would think that university records would be something that is fairly accurate and complete and all this sort of stuff. It's absolutely not. So I thought it would be helpful to just kind of give you a sense of what's happening in this do file. There's a lot of merging that tends to happen. So I get sent like Excelling at Iowa data and university records data, and I need to like stitch them together. That's what this kind of merge stuff is doing. There are also a number of transfer students who complete Excelling at Iowa that we don't want. So I need to like drop the transfer students as part of this kind of merging. And then I'm like, I want this to be a data set, not an Excel spreadsheet. So I create a placeholder essentially for this data. There are also a number of columns, in particular Excelling at Iowa, that are not helpful for quantitative analyses. These are all text columns. So we kind of just kick them out to begin with. There are also some students who are not part of that first year cohort that we kind of need to boot out. So there's already some trimming down that's kind of happening within the file. And then it's a process of cleaning demographics. We had both sex and gender data, and we wanted to try and holistically represent people, mostly by how their gender was, how they describe their gender. And so we have just code and code and code of like replacing all of these things and creating different binary indicators for us to ultimately use in our models. Another thing to note is that, and then we also had race and ethnicity. So like the cleaning file itself is like 1,000 lines of code because it's just getting everything ready to go. And so here we have some of our, what is our first gen status stuff, and then creating our comparison groups. That's down here. Another thing that I wanted to point out here is that sometimes when folks give you Excel spreadsheets and a column is like attempted credits, which is ostensibly a number, sometimes data doesn't read it as a number. So you need to like clean it up. And so anytime that there's like this null field in here, like if there's text and numbers, Stata automatically treats it as a text field. So there's a lot of like trying to figure out what the problem character is, removing it, and then using the dstring column to be like, this is a number, treat it as a number.
That happens in every package as far as I know. If you have words and numbers, it becomes string.
That was a very challenging thing for me as a first-year PhD student who's like, felt like she was in over her head to figure it out. So if I can help prevent that for you all, I will have succeeded. Ignore this, but this is, I created the data a little bit easier in terms of the outcome that we're going to look at is sense of belonging, and it's actually on a 7-point scale. I didn't want to do that to you all and have 6 submodels that we were going to have to keep track of, and so I just kind of collapsed the options. Essentially 1 through 4, I did it more numbers wise rather than chunking it anywhere. But so if folks responded to this Likert style option with either 1 through 4, they were considered a low belonging student. 5 and 6 was a medium belonging, and then 7 was considered a high belonging student. And then this last stuff here, is just, I'm consolidating the data to what I need. I don't normally do this in my cleaning file. I normally do it in my analysis file of like, these are the students I'm looking at. But these are just some rearranging commands in terms of trying to keep your data set more manageable in Stata.
Hey, Nikki, I have a
Yeah.
question for any of the research stats people in here. So what are things that you might need to consider when combining categories of data, like for belonging? Are there things?
I think that's a good question. I think there is you should probably represent your data as is. There's a very strong contingent that like, if you have 7 categories, maybe you keep it at 7 categories. I'm less certain about what rules you may or may not use to combine things.
I think it depends on the relative frequencies. Like, you only have one person who gives you an answer of 1 on a 7-point scale. You can't do anything with that.
Right.
So at some point, you will end up with models that break or have, there's a phrase for it called like the complete separation, I think. Like if you have a category where everybody is a constant with respect to your predictor in that category, then you can't have a relationship. So things start to break when you get small cells of cross tabulations, and that would guide where you have to collapse even just to make it go.
Yeah.
So, but I agree, like, don't do that unless you have to, as a guiding principle.
Yeah. When I originally did this, the like 1, 2, and 3 category were really low. And so I was like, I'm going to make this a little bit more comparable to your example. And that's why I did it, in complete transparency. And then I also just want to highlight this line of code here that I have currently grayed out. This is like a good check. I can do a lot of things in Excel a lot faster than I can do in like actual statistical packaging. So sometimes I just like export the spreadsheet to check to make sure coding is behaving as properly and whatnot.
But never merge that way.
Correct.
Never ever paste Excel data sheets in together as a merge.
No, use VLOOKUP.
Yeah.
At a minimum. Excellent. Okay, so I just wanted to showcase some of my like cleaning stuff. Cleaning, I think, takes some of the longest time.
Well, both you and Bladimir now have examples that everyone can use. To, like, how do I do a merge? How do I do a recode? How do I do a rename? Like, you both have that as a template now.
Absolutely.
That should be helpful.
Absolutely. Great. I don't know. Oh, no, wait, no. I might be able to do it.
Okay.
Yes. Okay, right click.
Right click.
No,
and then
but I
open
need
as
the
text pad.
analysis. Open
By
with
the way,
TextPad. There we go.
This package is called TextPad, and the reason that I use it is because there are user-defined syntax definitions that you can download for different computer programs, and so that's why even though this is just a text editor, all the colors are for Stata because it has a Stata add-on in it that someone made that colors things up. So it doesn't get it exactly right. Like, you can see that the comments that the comments that are at the end of a line don't turn green, but the ones that are like that doesn't turn green, but it does get a lot of it right. So that's how I build my handouts.
And these like are also supposed to be green.
Yeah.
So, yeah. Okay, so, oh wait, no, I don't need this one anymore. Because I want to show the Word document.
It should be in that same folder.
Yep. Which I did color code correctly. Okay.
Manually.
Yes. I mean, yeah, because I couldn't figure out how to do the export thing. But it didn't take me as long as I thought it was going to. So this is essentially the log file that I also included in the output for you all. Maybe? No, I didn't. So this embeds both the syntax and then the output, essentially. So the first thing I did was limit the sample, and this time it was more based on the response, or like if I had values for the predictors I was interested in using. And so for context, again, we're predicting belonging. It's got 3 levels, low, medium, high. Whether or not folks participated in first-gen Hawks, whether or not they lived on campus. So if they did, it was a 1 in this variable here. The number of times students went home. Now, this was asked on a survey, which gave folks options. So I should potentially maybe treat this as more of an ordinal type predictor because the last one was 5 or more. And for the sake of simplicity, I'm treating it like a quantitative predictor. This is relatively early in the semester, so they shouldn't have gone home a whole bunch of times. The time spent in a student org, similar thing there where they treated, they had like response options and then there was a like plus kind of on the last category. Again, I'm just treating it as a quantitative predictor. And then this is the, are you part of that first generation comparison group? So that's broadly kind of the variables that we're playing with. The codebook command just gives you details about particular variables. And so it's really helpful to see like if you have missing data or not. So for example, on belonging, we have 415 missing responses. And then because I have this actually in a loop, this is actually going to run through all of these variables and run that code repeatedly. So it's really like codebook belong, codebook first gen Hawks, codebook on campus until you kind of get through the end of that. And so I'm going to scroll through this because it's just kind of checking stuff. The TLDR for those things is that 415 kind of missing response options are folks who didn't take Excelling at Iowa at all. So there wasn't like super missing across items. It was a consistent like 415. And so then I drop the missing. So I'm dealing with a complete data set with all variables having non-missing cases. So as always, we do some descriptive statistics and we see that about 14% identified as feeling a low sense of belonging. 57% were somewhere in the middle. And then the 28%, 29% was a high belonging in terms of the sample. Which generally, like when I was looking at the entire variable, it was very skewed. We had a lot of responses on the top ends, essentially, and fewer in the lower categories. So as always, we estimate an empty means model. And so if we have 3 outcomes, how many submodels are we going to have? Yeah, 2, right? Does anyone want to try and interpret this intercept? That's okay, I got this one.
Can you scroll in a little bit, please, so to make it bigger?
Yes, absolutely.
It's 1.83.
1.83. Okay, so since we're in the low submodel, we're essentially predicting higher than low belonging, a low level of belonging. So this is in Logits because we're using the go logit 2 command here. And the expected logit for higher than a low belonging is 1.83. So if we move on to this one, now we're predicting higher than some, which is that middle category. So this is the expected logit for some belonging is negative 0.91-ish. Great. I've got our standard kind of extra commands that we ask for in terms of asking for the negative 2 log likelihood for Stata folks, asking for AIC and BIC, calculating some margin margins for our probabilities, and we see 0.38, 0.57, and 0.87. Is that
Nikki, I'm sorry, but
Yeah.
sorry to interrupt, but could you please repeat the how to interpret the intercept, because I'm not quite sure if you used cumulative or baseline, because I was kind of mixed up. Could you please repeat that again?
Yes, absolutely. So this is, it's funny that you mentioned that because there aren't any like extra commands over here. So it's a cumulative based on the categories here, how they're worded. So because it goes from low to some, and then I know that there's a high one, I know that it's predicting a cumulative model. And that is one of the benefits of running the empty means model to see which way we're going. Great question.
So does that mean that the first submodel, low belonging, has low versus medium and high belonging?
Yes. Yep. So on the low side, we have low belonging. On the high side, we have some and high.
Okay.
Yep.
Yep. And the second, that means the second model is low and some versus high. Is that correct?
Low and some versus high. Yep.
Oh, okay. Yep.
Yeah. You got it. Great. Do you want to add anything?
And are these intercepts or thresholds?
Are these intercepts or thresholds?
We'll end on that note. Which are these?
Intercept.
Yay!
How do I turn them into thresholds?
-1.
Multiply by -1. Yes, and that's why she's using GoLogit too, because it gives you intercepts. Regular OLogit gives you thresholds.
Yep.
And it's 313.
Great. I think we'll call it here for now.
But for now, yes.
Yeah.
But then we'll pick up the exciting conclusion next
Yes.
time of what predicts belonging in first generation students. So, questions for our presenter before we call it a day? All right, well, thanks for being here then. We'll pick this up on Thursday. I'll let you know when your new count stuff is up. Probably sometime tomorrow or Thursday morning at the latest. All right, thanks, folks. Bye, Zoomers. Bye, Roomers. And I can get Stata updated on here for you if you need it.
It means